Hello everyone, I'm Weiwei from Sony. It's my honor to be here to share with you our paper, Not Just What, But When, Integrating Irregular Intervals to LLM for Sequential Recommendation. This is a joint work with Takuma Udagawa and Kai Tateno. So in our work, we focus on sequential recommendation problem. So in previous sequential recommender, we found that some of the work focused primarily on item sequences, which overlook the temporal dynamic. So in this figure, this is an example of user purchase history. So we can see for each purchase items, there's a timestamp, like a purchase timestamp. And if we calculate the time difference between two consecutive items, there's a time difference, right? And we call it interval, which is 5 days and 10 days. So in our work, we want to include this information in our model. So our research question is, how can we effectively integrate time intervals into LLM-based model? Here's our proposed method, interval LLM. Because we want to apply LLM as recommender, so we have two input, item and interval. So we use an item embedder and interval embedder to map items and intervals into the language space. After getting the item embedding and interval embedding, we use, because we want to model the relations between interval and item. So we apply attention to separately characterize the importance of both items and interval, and then aggregate corresponding weight. So to frame all the information together and input to LLMs, so we need to design the prompt. But when we apply in the previous work, we found that generation-based recommendation might lead to ambiguity, which means that the output might have some misspelling, or even recommend the item which does not exist in the item set. So we reformulate the task as option-based generation problem. So this is our prompt. So in our prompt, we list all the historical information, and we give the following candidate. For example, here, 20 game options. Option A, first candidate, option B, the second candidate, and so on. And in this example, the model output option B. In the end, we want to bridge the gap between general text generation and recommendation. So we fine-tune LLM by LoRa. So this is our framework. And in the experiment, we run on Amazon review dataset with 5 core settings. And we compare with several baselines, including traditional method with and without interval, and LLM-based recommender with and without interval. So here's the overall result. First, we want to compare between without interval and with interval. For example, SASREC with T-SASREC, llama and llama at interval. And we can see that the performance improves when adding intervals. And so overall, our method reached about 1.3% to 9.6% performance improvement. The next question we want to tackle, so as is, can we benchmark and address the co-star problem from perspective beyond just user and item? So as the last presenter has mentioned, co-star problem is a very critical issue in recommendation domain. And most of the work focuses on co-star user and co-star item. And in our work, we want to point out another perspective, which is interval co-star. So in this page, the red icon means warm user, which is warm user or warm item. And the blue icons means co-star, like co-star user and co-star items. So in the left-hand side, user co-star, which means, for example, like new users to the platform, which has fewer interactions compared to other normal users. And in the middle, item co-stars means the new, for example, like the new items to the platform, which has fewer interactions compared to other normal items. And in the same sense, we propose interval co-start, which we want to point out the users has a longer time interval compared to other users. So we first calculate the average intervals for each users. For example, the blue users here, the average interval is 2 years. And the red user here, the average interval is 1 year. So the blue users is a co-star interval users compared to the red one. Okay, so this is how we defined interval cold start. And we benchmark all the methods from these three kinds of perspective: user, item, and interval. And we can first see that our proposed method performs the best across warm setting, cold start setting, and overall setting. Because we want to know the performance drop between warm and cold, so we propose another evaluation metric, which is the difference to evaluate the performance drop. So first, we can see that if we incorporate intervals, it can lead to a smaller performance drop in most of the setting. And if we further compare different perspectives, like from user cold start, item cold start, and interval cold start perspective, we can see that the performance drop in the interval perspective is larger than in user and item perspective, which means that we believe that the interval aspect has been largely overlooked in prior research. Okay. So in summary, we propose a method called interval LLM, which integrate time interval into LLMs. And we propose a module called interval-infused attention, which can capture the temporal relevance between items and interval. And in the second part, we propose a new benchmark to benchmarking interval cold start problem. And we found that our proposed method performs the best across all settings. So that's all of my presentation. If you are interested, feel free to check out our paper. And if you have any feedback, feel free to contact me. Thank you.
So the first question is, how do you encode time intervals for LLMs?
Yeah, so this is a good question. So in our prompt, we have included a text-based interval, which is the T1, which is like a text interval, for example, like 1 month, 1 day, like that. And we also include the embedding, which is a Z1 here, like Z1 here.
Okay.
And we use a special token, interval and slash interval, to locate the embedding.
And Z1 is like a number or
It's
period?
It's an embedding, so we get the interval embedding from the interval embedder.
Okay.
Yes.
Right. Okay, and the second question is this method limited to recursive, similar-related items purchase? How is the performance about more exploratory item choices for the user?
Right now, it just so in our work, we just benchmarking the overall result. We didn't group by like different kind of users, different kind of items. But I think this is a very, very interesting question, and we would like to investigate in the future.
Yeah, thank you for your talk. Really interesting. Actually, my question is close to the previous one. I mean, you've showed interval embeddings and infused attention, but I still have a question. Have you tried some more easier baseline based on, I don't know, just kind of cutting embeddings or probably adding them like in positional encodings, some sort of this one?
Yeah, it's a good question. So in our paper, we have included an ablation study, which we tried a more like easier baseline. For example, we just using the text and input it into Llama without embedding. And also we try to only include timestamp instead of using interval. So yeah, feel free to check out our paper. We have more experiment on this part.
Do you treat interval as discrete or continuous features?
We treat it as continuous feature.